Hello there. In this video we will explain the differences between rigid body physics types: dynamic, static, and kinematic. The selected body type defines the rigid body 2D's movement behavior, position and rotation, and collider interactions. When a body type changes, Unity recalculates various mass-related internal properties, and all existing contacts for the collider 2Ds attached to the rigid body 2D need to be re-evaluated during the GameObject's next fixed update. Depending on how many contacts and collider 2Ds are attached to the body, changing the body type can cause variations in performance. The properties of the rigid body 2D component in its inspector window differs depending on which body type you have selected. Dynamic. Use the dynamic body type to design your rigid body 2D to move under simulation. Kinematic. Use the kinematic body type to design your rigid body 2D to move under simulation, only with explicit user control. Static. Use the static body type to design your rigid body 2D to not move under simulation. Dynamic. The dynamic body type is the default body type for a rigid body 2D, because it is the most common body type for things that need to move and is designed to move under simulation. All rigid body 2D properties are available with this body type, such as finite mass and drag, and is affected by gravity and forces. A dynamic body will collide with every other body type, and is the most interactive of body types. It's also the most performance-expensive body type, because of its dynamic nature and interactivity with everything around it. Static. A static rigid body 2D is designed to not move under simulation at all. If anything collides with it, a static rigid body 2D behaves like an immovable object, as though it has infinite mass. It is also the least resource-intensive body type. A static body only collides with dynamic rigid body 2Ds. Note: having two static rigid body 2Ds collide is not supported, since they are not designed to move. Kinematic. The kinematic body type rigid body 2D is designed to move under simulation, but only under very explicit user control. While a dynamic rigid body 2D is affected by gravity and forces, a kinematic rigid body 2D is not. Because of this, the kinematic rigid body 2D has a lower demand on system resources than a dynamic rigid body 2D, allowing it to be simulated faster. If you have any questions, feel free to leave your comment down. Thank you.